All right, we're at the end of chapter 9, all about quadratics. We finally get to the quadratic formula. The quadratic formula, simply said, is this thing right here. And what it's used for is finding those x-intercepts. What are the x values? They give you a y value of 0 in a parabola. And I would probably argue it's the best way to find the x-intercepts if you have one of these quadratics. You can do the factoring, you can do the graphing, if you have square roots for sure, if you don't have this bx term. But for the most part, this is going to be the way people used to find it in the real world. So, okay, want to make the point though it only works when y equals 0. In other words, you have to take your quadratic something like this here. You have to make one side equal 0. And that's going to pop up on the test and some of the homework, so you got to make sure you do that first. Let's go through, do some examples, and we'll figure out this discriminant thing, and we will be done with the chapter. All right, so if we have one like this here, solve 10x squared minus 13x equals 3. So first thing we have to do is make that equal 0. So we're going to subtract 3 from both sides of the equation. And that gives us 10x squared minus 13x minus 3 equals 0. So now we can actually plug things into the quadratic formula, but first I want to just kind of remind you that we said the quadratic was ax squared plus bx plus c. So often I'll go through and write out just on the side, so I don't need to keep going back to it, what a, b, and c are. So a is that x squared coefficient, so that's 10, the number in front of x squared. B is my x to the first coefficient. You got to be a little careful. That's going to be a negative 13 right there, because it's plus bx in the general equation, so it's plus a negative 13x, and c in this case then is also going to be, a negative 3. So you can write these off on the side if you want to, but I would love to see you actually write out this quadratic formula and then plug your numbers in. So b squared minus 4ac goes in here. Make sure your radical does extend all the way past the c, and then all that is over 2a. Now for showing your work, if you could make sure you write what your numbers are when you first put them in. So I have negative b, and b is a negative 13, so the negative of negative 13 gives me a positive 13, plus or minus, square root. Now I have this negative 13 squared. We're going to come back to that in a moment. Minus 4 times a, which is 10, times c, which is negative 3, all over 2 times a, or 2 times 10. Now I put this first example in here because I want to make a point of something. Lots of calculators are going to do this wrong. They're going to do negative 13 squared wrong. So you have a couple options. We've talked about all these before. You could take and you could put that in parentheses if you wanted to. You could, if you know negative 13 squared is 169, you could just type 169 in your calculator. What I do, honestly, is I just change that to a plus. I kind of treat it like absolute value. But make sure you navigate that first part correctly. And I'm going to go through and simplify it this way. I'm going to keep my 13 there in front, plus or minus square root. And I'm going to punch in all of this stuff into my calculator in one shot. So negative 13 in parentheses, squared, minus 4 times 10 times negative 3. That's going to give me a square root of 289. And that's all divided by 20. All right, so we have that done. Now I can do square root of 289. That nicely works out to be 17. So I have 13 plus or minus 17 equals 20. And perhaps I should have been writing x equals for all these steps, but I'm up to there. The reason I like to break it up that way is when you get to Algebra 2 in a couple years, you're going to start doing some of these square root of 289 where it's not going to nicely give you an integer answer. You're going to have to break it up into a couple square roots, and so if you get in that habit now, it might make life a little easier later, but you don't have to. But most of our parabolas, most of the time we found we had a parabola that had 2 x-intercepts, so we'd have something like this. And that's how you get this 2 x-intercepts are going to be this plus and minus right there. That one of them is going to be with a plus sign, so x could be 13 plus 17 divided by 20. Or the other option, x equals 13 minus 17 over 20. Now punching those in, you have to be careful either to do the top part and then press equals and then divide by 20, or you could take and put it in parentheses. What I like doing is putting it in parentheses like that, typing this whole thing in at one time. So that's going to give me 30 divided by 20, or x equals a 1.5. And then what you could do with the graphing calculators at least is press second and then enter to get the exact same equation to pop up on your screen. Or you could do your up arrow if you have a scientific calculator. And then you just go back, and the only difference is make this a minus sign. So you can use your arrow keys to get to the plus, hit minus, hit enter again. And that's going to give us a negative 4 divided by 20, which reduces to negative 1/5, or x equals negative 0.2. So this one's going to have 2 x-intercepts, and there they are. So that's the quadratic formula. I'm punching it in to get an answer. You'll see kind of variance on that same thing, and you'll see some on the test. We can back up and do a little bit. There's this thing called the discriminant. And the discriminant tells us which type of quadratic we have. And I'm going to jump ahead a little bit by kind of what I mean by that is as we go through and we're looking for x-intercepts again, well, one option is going to be like that last example. You're going to have a parabola that's going to give you nice two solutions. And it's possible to have another parabola that comes down and just kisses that x-axis, then comes back up, only has one solution. And it's possible to have a parabola that is either all up above the x-axis or all down below and has 0 solutions. So we have 0 solutions. The middle one has 1 solution. And this first one has 2 solutions. And if you don't want to go through and do the whole problem, if you just need to figure out is there a solution and is there 1 solution or 2 solutions, you could do something called this discriminant. And I want to go back up and look at the example we did before. And the part that gave us 2 solutions, we said, was this plus or minus. And that the plus or minus, 1 solution was when we added, and 1 solution was when we subtracted. Well, this number here then is going to be important. That's what they call the discriminant. Well, it's related to that. Really, the discriminant is this part here, this b squared minus 4ac. I want to make a point, it's not the square root of b squared minus 4ac. It's just b squared minus 4ac. And if we look at what kind of numbers are going to give us 2 different solutions in there, well, we had 2 solutions in this example. We had a positive. Because do you agree you could do the square root of a positive and get a real number? And then that real number, you're going to add it to get a solution and a solution. So I'm going to go back down here to my page, and we'll fill in a couple things. So the discriminant is b squared minus 4ac. It's the thing that's inside that square root. And when we have 2 solutions, it's going to be like that last one, b squared minus 4ac. That is going to be greater than 0. Because if what's inside that radical is greater than 0, we can square root it, and we'll get a positive real number that we could add to that negative b, add to that thing and get an answer, and subtract from it and get a different answer. If we're going back before with 1 solution, there's only 1 possibility that'll give us 1 solution. And I don't think I'd mess up your work with this, but if this ended up being a 0, if you have square root of 0, that's going to give you 0. What number times itself gives you 0? That's 0. So now 13 plus 0 divided by 20, and 13 minus 0 divided by 20, you're only going to get 1 answer, because adding 0, subtracting 0, either one just leaves you with 13. So the possibility then for getting just that 1 solution, if we were to have a graph like this middle one down here that only has 1 x-intercept, that's going to come from having the discriminant, b squared minus 4ac, has to equal 0. So that'll just give us 1 answer. And the thing that would give us 0 solutions has to be the other. So we looked at this first one. Well, discriminant could be positive. Discriminant could be 0. The only other option is going to have b squared minus 4ac could be less than 0. And the reason that gives us 0 solutions is as we go through one of these problems, if you try to do the square root of a negative number, you get an error. So if we have this negative right here, any negative number, as soon as you do the square root of that, you come up with an impossibility. You don't get a real answer, you get an imaginary number answer. You'll learn about those later in life. But that prevents you from being able to do this step here, because you can't add 13 plus an imaginary number or an error like your calculator may be showing you and get a real number answer. So that's going to be our discriminant, b squared minus 4ac, not the square root of it, just what's inside. And then the 3 possible cases. So now we get a question like this. An object's height is given by h equals negative 16t squared plus 35t plus 1. Does it reach a height of 20? Well, what we could do is we could take and say, all right, this equals 20. So I have negative 16t squared plus 35t plus 1 equals 20. So I could go through, and first, like we're doing in all the questions this chapter, we need to make one side equal 0 before we can really do anything with it. So I get a negative 16t squared plus 35t plus, minus 19 equals 0. Now from here, I could try to solve it by factoring. I could look at completing the square. I could do this new quadratic formula. But if I want to save some time, I'm really just trying to figure out which one of these situations is it. So if I want to figure out, well, does it go, they'll be opening the other way, but does it go up, hit that height of 20, go higher, and then come back down and hit it again on its way down? Or does it go up and just hit 20 and then come right back down? Or is it all down here, there's no x-intercept, it doesn't hit 20? Because when we subtracted 20, we kind of took our problem from a height of 20 and moved it down to where we're just looking for the x-intercept now. That's kind of our new height of 20. So does it hit it twice? Does it touch it once? Or does it not get there? All we need to do is do the discriminant and figure out which one of these 3 cases are we in. So if we would say b squared minus 4ac, b squared minus 4ac, b is going to be the x to the first, or in this case the t to the first coefficient. So that's going to be my 35, so 35 squared, minus 4 times a is what's in front of the variable squared, so 4 times a negative 16, and then times c, which is a negative 19. If I take and plug all those into my calculator, I end up getting a 9. So it's clearly in this first category, it's a positive number, so we know this object is going to go up past that height of 20, go a little bit higher, and then come back down. So that's pretty much it. Really the only last thing is which method do you use? On the test, you're going to get some questions that say do this by factoring, do this by square roots. And generally I'm going to give you, for the factoring one, what's one that's good for factoring? For square roots, which one that you nicely do with square roots, and so on. This here, I slurped that from the back of the book. That's what you can do. This, honestly, is kind of how I'd go through and do it, because you will get a few on the test that say, hey, do it however you want. But if there's no x to the first term, if you just have like a 5x squared plus 7, if you don't have that, I would definitely go and do square roots. So use square roots. So get it to where you have the x thing squared by itself, square root both sides, absolute value of x, and go from there. If you have both an x squared term and an x to the first term, I do what we did in this section and use the quadratic formula. That, my friends, concludes Chapter 9. Let me know if I can help you in class. And subtract it.